Hello and welcome to the Kentucky Water Fuel Museum. I'm James Roby, curator of the museum. In 1996, an interview was conducted with Herman P Anderson, the water fuel inventor who converted this 1971 Ford LTD to run on water in the early 1980s. Dr. Cliff Ricketts, professor of agriculture at Middle Tennessee State University, is the man conducting the interview, along with his associates. Dr. Ricketts and some of his students have been running cars on hydrogen from water for over 15 years, using solar electric panels to provide the electricity to perform the electrolysis on the water that is then stored in tanks and used on a vehicle. The video is of very poor quality, but the information contained in it is priceless, and I hope you enjoy it.
And tell us what's inside that little round box, that generator over there again. Explain that to us.
Yeah, well, I was explaining it.
Yeah, but we didn't get you on tape, though.
Yeah. See, I've got the cathode and anode. I've got that plated there. See, inside of it, it's a soft iron core. See, inside of both anode and the cathode. See, I do that for the reason because I'm getting my magnetics right to it. See. It's very important if you're going to make this hydrogen pass, see, that you do that, see. And of course, you got to have your cathode and anode separated just the right place here, because if you don't, and making it pass that way, and without the divider down in there, see, you can't use the divider down in there. You got to use it up above, see. You get a certain proximity here, see, and if you get it too close, you'll create a magnetic storm in here, and it won't do anything. It'll just blow around like a tornado, see. See, if you could see in that, I had generators that I could see in there, in the sides, and see exactly what it was doing, see, and I could get my proximity just right, see. You won't, because you're charging these anodes now, you see, with this high voltage, see, and you charge it them.
Now, is the high voltage hitting inside that generator?
Magnetically, and it's passing this electricity, see, and making this deuterium in there. You want it, your magnetics is right. On your cathode, you got a negative electrode there, see, and on your anode, that's a positive electrode, see. Well, you're splitting this hydrogen over on the anode side, see, into oxygen and hydrogen. That's where you split it, see. And then your hydrogen ions go through your electrolytic or the electrolyte over to the cathode side, see. Well, in order for that to do it fast, see, you got to make this. These cathodes and anodes, the electrodes, you got to turn them into like a magnet, see. And then your positive, magnet, see, your positive pole. This is just like a magnet now with poles. Your positive pole, see, and your hydrogen ion is positive. And this over on your anode side, that's positive. Well, what does positive and positive do? It pushes it off, see? And that pushes this hydrogen ion really fast, see? Really fast through this electrolyte, and gets it over there on the, and then they on the cathode side, that's negative, and that just pulls this. These hydrogen ions in there, just pulls it into the cathode, see, and there is where you catalyze the hydrogen. See, there are ions there, see, over there, and make a molecule of gas. See, H2. You see, then catalyze right on your cathode. To form your hydrogen gas. See, but in the process, going over from your anode to your cathode, see, you come in with your radiolysis process there, see. You're changing these hydrogen ions, see. You're doubling your atomic weight and you're doubling your You're energizing, you're doubling your power, you're doubling everything, see. And you're doubling your mass density, see.
Critical.
And that's what gives you your power, yeah. And it's all done just instantly like that, automatic. And see, when it gets over on the calcium side, it's already into the deuterium now, see. You get what I mean?
Didn't you say hydrogen comes out of here? In here?
Yeah. This just turns the hydrogen into a hydrogen isotope, see. It's just another form of hydrogen. Like heavy water. You know how you make heavy water? You know, for the nuclear bombs and everything? That's what you're doing right here. You're making heavy water. Yeah, but you got to use insulation or shielding. You see, and where you got these two cores. I got a Maurer cores. They go on the race cars, and they hooked them together. See? 35,000. What you use in race cars. And I got two of them. That gave me 70,000 volts to change this hydrogen into deuterium. See, they're standing wave frequency in between a microwave and a hard X-ray, which is called soft X-ray. See, to get it into that. Now, if you had more. Go on up that you'd be changing it more into hard X-rays, see? And you don't want to do that, see? It's very important to get that 70,000 volts in.
What do you call it, soft X-ray?
The frequency in between microwaves and hard X-rays. That's a soft X-ray. And that's a 7.5 cycle per second.
This valve over here increases pressure going to the engine.
No, it doesn't do that. It gives the engine what it's demanding, see, and it just saves hydrogen, see. Otherwise, it would be pushing this, with this type of carburetor, it would be pushing this hydrogen and a deuterium right through the carburetor and be wasting it like if you were standing sitting there at a red light, see, and that's making that hydrogen, see, over here, and push in here to a certain pressure there, see. It just gives, when you feed it, step on the accelerator, see, and demand more hydrogen to run your engine, accelerate the engine up, see, well, this will give it whatever it needs, see.
Okay, that is a propane demand.
That's a propane demand. Okay. Now, this stuff, it was hard to get, see. I had to get that pressure valve out of Minnesota.
Is that where the pressure increases right over there? Is that it? Is that the pressure increase?
That keeps the pressure from getting too high, see. Generating, yeah. If they get pressure, it keeps making this hydrogen, see, in that generator. And if you're not using it, it'll keep on making. If you don't have a device like that, it'll keep on making it and blow this up. It just cuts this system off from your battery, see, through a solenoid over here. See, you're using this as you're making it. This is the system here. That you got a little factor right here.
Okay. This gauge right there.
Oh yeah, that's just pressure gauge. That's all. There is the thing over here. Now, it'd be hard to get. It'd be hard for you to get one of these. I got that out of California. You can mix this. I use this with gasoline for about 2 years before I ever started on the hydrogen. Mix it and it works. He gives you about 4 or 5 miles to the extra gallon. I was mixing the water with the gas.
Oh, the water.
No, okay. And I was getting about 4 to 5 miles extra miles out of my gasoline. I knew one of those that we used on the P-51, see, and I knew all about that. I knew what that would do, see. And that has an impenger in there, and that's forward. Now they built a bunch of these things, and they never did work. Ford Motor Company, General Motors built them, put them on Cadillacs, and never did work because it screwed up. Well, this Robert Billings, he has one. You see, injectors in it. None of that stuff was, because they didn't put it into a fog. See, they just put it into a spray, and that's no good. That puts it out. See, it's like throwing water off. Well, this fogs it in there. It's got an impenger in there. See, and it brings this water in there and breaks it up in little drops. Then it impinges it against this plate in there, and that breaks it up into a fog. See. And all that mixes perfectly with your hydrogen then, see. And it raises the mass density, and it doesn't keep it from firing and burning. It just burns perfectly.
Now, here's the $64,000 question. I asked you this before, and I want to ask it now. We're on tape. In my opinion, this is one of the greatest discoveries of mankind.
I think so.
Why hadn't it moved forward?
Why hasn't it what?
Why hadn't it got past you? Does people not believe you? Or why hadn't you done any more with it? I don't understand why you parked a car that's running this great with this great technology.
Well, it's not going to work with the general public.
Now explain it to me now.
I thought I'd already explained that. You got to be an engineer. You got to be a nuclear physics to keep this thing running.
Why? Explain that to us.
Well, you got all this radiation now. You got to keep your pH factor up on that, you see, to make your hydrogen and then your deuterium. You got to be an electronics engineer and nuclear physics. Well, there's so many different things. That you see, you've got a little factory on the hood, you see. And it's just like a man working on a factory. You got engineers in there, you got different people that do different things, and you got to be it all, see. You got to do it all. The driver, it's up to him to get it all going, see, and keep it going, see.
Now, I don't know how a computer works either.
And the general public, everything is convenience now. They're not going to fool around here and look for water, everything. They going somewhere in a hurry. They want everything under there and going. They don't want to have to fool with it. They will not fool with it. That pH will last you for 6 months, see. And then you got to put some more in, see.
How much? Better than an oil change.
Yeah.
How much that you said? Potassium hydroxide.
Potassium hydroxide.
You pour it in that cap right
You
there, right?
pour it right in that cap.
Right.
Yeah.
Oh, you just monitor the pH.
Yeah.
You set your pH for 12. What'd you say? 12, 10?
12.
12. Okay.
I just did this enough to this to show that it would work. See? And there's a lot of things that you would need on here. See, you could use on here. You could use a condenser. See. And condense your exhaust and reuse your water, see? You could do that, see? I don't have that on me. But see, Billy's, he's got a patent on that, I showed you. Every time, you got to set this system up for the size engine you have.
Okay.
For the cubic inch engine you have. Now this is a 302.
Okay.
All right. You have one in this hydrogen carburetor, propane carburetor, what I use, see? But it works good for hydrogen, see? You see, I have to turn this upside down to keep from making a hole in my hood here. I had to get an adapter. Otherwise, I would have just set that right on top of the carburetor, but it would have stuck up through the hood. And I didn't want that, so I happened to find an adapter, and I turned the carburetor upside down. It don't make any difference about that, see, using that. But you're not going to have the room, and like to change it in a new car. The government wouldn't let you use this, see. These people right here wouldn't let you use it. You see, you got to get approved by these people right here, like I did, to get out on the road with it. It ain't going to do you no good sitting in your garage. So you see, this is electronics. It's not, it doesn't put out radioactive radiation.
Okay.
What kind of rays are we talking about? Alpha rays, gamma rays, beta rays? What kind of radiation that you get if you were standing around it and it was operating and you weren't on the shielded side of it.
You got EMF.
EMF waves. Well, that comes off a high tension wire too.
That same thing comes on by the
Oh no, that's not that dangerous.
The hell that's not.
Really?
Red blood cells on the hell.
Oh really? That wouldn't be good. You get AIDS or something that way.
That much voltage, 70,000 volts. We're using 22 ounces. It's going to take you 22 ounces to change it. To change it. It's going to take 22 ounces to do that. But it don't know when you change it into deuterium, it only takes 11 million. 11 million. 11 million.
See, even if this were possible, the government wouldn't want it because there's no way to tax it. You have to make the hydrogen, you have to make the hydrogen a fuel cell and have it distributed at a gas station and have an inventory control on it so they can have a tax base, or else it's not going to go.
You say that's another thing. See, I should have told you. What about the taxes on this? And I like to drive this car on the road and pay no taxes on the fuel.
Let me ask you this question.
The state's not going to do that. The government either.
Do you personally feel safe with it?
Oh yeah, I do.
So you're saying,
I feel safe. Yeah.
so you're saying
I've got this far
the
safe.
government won't let you do it because of their perceived danger.
That's right.
But you're not worried about it personally.
No.
Obviously, you wouldn't be as healthy as you are all the time you spend around it.
That's crazy.
Have you done anything inside to the engine?
No.
Inside of it, no, it's going through.
Okay.
No.
So this is really
All I've done is change the climate for the house.
just a time. And you used a basic propane carburation system, gaseous system.
Right.
Explain to me that process right there again now.
Well, your radiolysis
Radiolysis, okay.
it works off of a high voltage system. See?
Okay.
70,000 volts on a 12 volt system.
Okay.
We'll do it, see. And you change that radiation. It's electronic radiation, see.
Okay.
Using electrons, see.
Okay.
Into a standing wave system there, see. It's like what you use to get cold fusion, see. A standing wave is a continuous wave. See, if you get the oscillations there just right, and the frequency just right, a standing wave frequency will continue to operate. It's just like through a lead crystal. See, radio waves coming through a lead crystal. Well, in that lead crystal, you set up a wavelength there of a standing wave, see, and that's why you can take a crystal radio and amplify the current coming in there without any battery, see, because you got a standing wave system. And the same thing applies here, see. You're setting up a standing wave system there, and it runs right through you from the anode to the cathode, see. And the fact of the matter is, of course, these hydrogen ions, it just pushes them right over there to the cathode and speeds up your time, it speeds up your production of hydrogen, see.
So really, except for that one piece that you give away, all the component parts are here.
Yeah.
So the bottom line is, it works. You
Yeah.
feel good about it.
Yeah.
But one, the government wouldn't let it happen because of taxes and safety, and the general public wouldn't use it because it was just it's just too complicated and could not be safe if something went wrong.
That's right.
Just like that little pressure valve, if it didn't work, it could blow to thunder, right?
Blow it up.
That makes sense to me.
It works.
All right, now let me review this process. We have to use the ionized or ozonated water. It's under pressurized system with solenoid valves and pressure gauges and so forth.
Yeah.
It goes into your specially designed generator electrolysis unit, which uses the cathode and anode. Somewhere during the process, when it goes from the anode to the cathode, you add radiolysis,
That's right.
which is a process that then makes that hydrogen into deuterium.
You call that the wires in there. You see, you call that the corona wire.
Corona wire.
You know about corona tubes. You use these corona tubes in making the ozone. Well, and it's something similar to a corona tube.
You have electrical field, basically.
You see, it's your high voltage discharge in there that does it. And that reverses the spin moment on every other one of your hydrogen ions, see, and draws it in to the nucleus of the atom. I got 59 years of experience working with cosmic rays and ions alone, see, and I specialized in ionics, see, and I coined the term for ionics, see, and I started that 59 years ago, and all my years of experience, if I hadn't had that, I couldn't have done this. Yeah, but I didn't intend to drive it at first, but it got to working so good and everything, I just kept driving it. I kept driving. This thing was about 15 years old when I put it on it. He doesn't only want a wet bubble with it. I don't think that. You see, that's the reason I recycle it. And I kept the temperature down. See, this stuff gets hot. It's hot in there. And if you get over 180 degrees, it's going to boil you. Yeah, you have to light onto it. It's going to become volatile. And it's going out through your hydrogen system. And you're going to lose it. And you're going to have to put it on.
It'll run your engine.
Yeah. If you do all that, see, and the wet bubbles and everything, and you got to keep those down, to keep those out of your system here, see. And then you do that by putting pressure up here, and putting a certain amount, you're putting 8 ounces of pressure on it, and that'll keep these bubbles pressed down, see, and they'll come out through this side, that hole right there, and come right up through this fan pipe here, and then right back down underneath there, right back into the system. And that is also cooling this and keeping that down below 180 degrees, because to keep it becoming volatile and keeping your wet bubbles, if you don't, they'll just boil up there, and if you don't keep the pressure on, and they'll get right in your hydrogen system, and they'll ruin everything.
Yeah, if it churns up and gets too hot, it starts to create foam.
Oh, yeah.
And it gets up in that hose.
Oh, it gets up in this hole, you're going to ruin everything.
It's like pouring sugar in a gas tank, basically.
That's right. Oh, you got to have all kinds of problems.
Anything else you want to tell us about this engine? We have about 5 minutes.
The silicon in there to keep that, just like a water pump, you get the fluid in there, and it's all hot. Now that may be added in there. This thing may be leaking all over, or you just have to almost build another. And you can have all kind of problems with this. You could run into it.
Space to put another one in there, huh?
And you got to take that one out and build another one, or rebuild them.
Let me ask you this.
See, all this is experimental and temporary. This wasn't made to put on the market. I didn't intend to keep driving it. All I wanted to do is just to prove this would work. See? And I kept on getting the bugs out there. Oh, I built 30 of these before I got money that would do this. At least 30 of them. See? All right. I had to experiment. No, this car is going in a museum.
Herman says in the interview that he gave the high voltage part of his system to a Donald Brisby. We caught up with Donald earlier this year and videotaped an interview with him about the application of the high voltage device to his chamber, which is different from Herman's, but the high voltage application is similar. Hope you enjoy it. So how did your high voltage get into your electrodes then?
I had an extension wire that ran around the whole unit to give it the radiation. But the wire that ran to that went round and round the whole unit there. You won't see it there because it ran around the unit.
In other words, did it go just around this drum here, or what?
Yeah, it wrapped clear around the drum.
So like a
Well, the same wire that came off of the coil, I just put an extension on it and ran it around there so that radiation would go right through the unit.
And then how often was the coil fired?
What I had was an extra distributor. I had an extra distributor that had the coil that furnished the, like I said, this has been 20 years ago.
Sure, yeah.
It furnishes the extra current that I put on the anode over here.
Mm-hmm. Anode meaning positive or negative?
It was positive. And it every time that thing turned over, it kicked 8 pulses in there. And I had the thing timed, I had the motor running fast enough that you were getting a continuous pulse.
Going to the positive wire.
Going into the positive wire.
Now, was this positive wire also hooked up to the battery positive, or was it just hooked up to that distributor?
Well, it's all the same because the coil ran to the distributor, the secondary distributor, and then ran to that anode there. And so what you had was the regular 12-volt battery on here, plus the 70,000.
So you did have the 12 volts also here?
Yeah.
Okay. And there was no feedback of that 70,000 volts going back to...
I had a diode in there.
I see.
That kept it from going back. That 70,000 volts ran not directly to this, but it ran through a spark. I had a spark. That means that the 12 volt with all the amps on the battery can't go back up the spark, but the high voltage can go in on the low.
Okay.
And so what I did, I got high amperage and high voltage because I used the spark.
So you had it jump.
I had it jump.
So that you couldn't go backwards on it.
So it wouldn't go backwards, that's right.
And you didn't have it do that inside the chamber, but outside the chamber.
Outside the
prior to connecting to this.
Right.
And that gave you gas production sufficient to idle this truck.
That's right.
You said you were running that extra distributor using a fan motor on the previous visit?
Yeah, same thing as this thing, little fan motor goes in here.
And did you have to change the RPMs of it, or?
No, just ran.
It really didn't matter. It wasn't that exact science.
No. All I want to do is pulse the current. And then all the 8 wires fed into the same junction on the thing, which gives you a pulse, a DC pulse, 8 times whatever the RPM is, and hey, it works fine.
Willard Elliott is a retired electronics engineer from Canada who recently paid a visit to the museum and was willing to offer his comments on the high voltage part of Herman's system.
Donald Frisbee constructed this to run his Ford truck on electrolyzed water. This is what's called a flip-flop. It has 3 2N3055 transistors. It has a diode. It has 3 capacitors and 3 resistors. And as we haven't analyzed the circuit, we aren't sure exactly what it is, but there's a potentiometer to adjust the frequency of the flip-flop. Now this unit drives this. This is a very large, heavy current, silicon-controlled rectifier, and it switches on and off the heavy current to the electrolyzer from the battery. And by using these 2 units together, you can create an on time and an off time of the current in the electrolyzer. And it's my understanding that he uses a 70,000 volt spark coil, which is wrapped around the electrolyzer, and it is connected in such a way that it operates on the water when this cell-controlled rectifier opens. So you get high voltage, low voltage, alternating by this flip-flop. And this apparently gave him enough gas to to idle his car, and the gas was completely generated by the alternator on his car. It did not, however, have enough power to move the car. It was just idling, and just barely able to idle. If he opened the butterfly valve to try and speed it up, it would stall. So that's what this unit is.
And it could be replaced now with what components?
Well, nowadays you would use a power MOSFET instead of this diode. And this circuitry here could be done with a 555 timer chip and suitable driving transistors to drive a MOSFET. So it is not as hard to do today as it was in 1980 when Donald built this.
But what about the air gap that he used?
Well, the air gap was the where the spark, the 70,000 volt spark went to the water when this was turned off. So the 70,000 volt spark went through an air gap to the two terminals on the electrolyzer. It was also wrapped around the electrolyzer, so you got both magnetic and plasma effect from that arc of the spark.
So he was passing the arc through his chamber.
The arc was not in the chamber, it was external to the chamber, but its effect was going in the chamber.
No danger of exploding the hydrogen gas in the chamber by that?
By the fact it's outside, it would not contact any of the gas. Well, if you had any discharge inside your electrolyzer, it would be destroyed by the explosion.
So the only energy inside the chamber was 12 volts from the alternator?
Yes, provided by this diode. And when the diode wasn't closed, the voltage from the spark plug of that arc also flowed through the electrolyzer. Well, the voltage would probably still be 12 volts, but it would fill in the period when this flip-flop was off. And there would be some spike put on the water by the fact that the spark flashed through the gap that was external, and the plasma there would create some effect on the water itself.
And so the purpose of the gap?
It's just to allow the spark plug coil to work, because if you don't have a gap, you're shorting it out and you won't get any current or any spark. You have to have an adequate spark area similar to you have in the spark plug.
So you could be achieving the radiolysis that Herman Anderson speaks of by using this kind of discharge of what he calls a corona discharge.
I guess some people would call that radiologists. It's really just a spark between two contacts, an open air spark.
Except that you're wrapping the cylinder, the chamber, the electrolyte chamber.
The spark plug wire is wrapped around the chamber, so the current in that spark also produces a magnetic field in the fluid.
But simply having a long spark plug wire wrapped around the chamber would causes
a magnetic effect.
So you basically want to wrap a spark plug wire around a chamber and terminate it with a spark plug, maybe just taped or strapped.
Well, I'm not saying you want to do that, but that's what Donald Brisby did, and it appeared to work.
So the end of the line is the spark plug, and in between the spark plug and the coil, you wrap it around the chamber. Is that the idea? We hope you enjoyed this investigative effort to find out exactly how Herman's car operated, and we hope that it inspires others to make similar progress in turning water into fuel.